The next thing that we want to be able to do is to figure out the volume of a three-dimensional solid if we take a two-dimensional shape, revolve it around an axis, and then that forms the solid. So we're going to take a look at this one here. We've got this trapezoid, and we want to revolve it around the x-axis with the line y equals 0. So if I'm looking at that line is going to be right here. We're going to be spinning this around that axis three-dimensionally. Now, some of you may have a hard time visualizing that, and I completely understand that. So I'm going to switch over to a different tool here that we can use to get a visual on what's happening. So on this tool, we can input how many vertices we want or how many corners we want, and then specify where those coordinates are. And as we do that, we can see that we've got the same trapezoid that we had on our original problem. So if I take a look at that, I've got a trapezoid and I want to revolve that around the x-axis. I'm going to come down here to where it says across y equals 0 and make sure that this number here is 0. And then I'm going to hit revolve. And what that does is that's going to allow me to see three-dimensionally what's being formed when I revolve that around the x-axis. So looking at this, it kind of looks like a cylinder, but we have that peak over here on the left side. So that left side is going to be a cone, with that right side is going to be a cylinder. So we have two different pieces to this that we need to find the volume of. So if I come back over here, if I were to extend this, I've got a side that would come down there. I've got a side that would extend right here. And then I've got that slanted piece coming up to the peak. And if I were to split this up, I've got a cone on this side, the left side. And then I've also got a cylinder on the right side. So this piece right here is going to be a cylinder. So we have two different volumes that we're going to have to find the total volume here. So I'm going to start with the cone. So if I want to find the volume of the cone, we need to remember the volume for a cone is 1/3 times the area of the base, which is a circle, so pi r squared, times by h. So if I'm looking at that cone, the radius is going to be the distance from the center to the outside. So the center being where this red line is, and the outside is going to be out here. So I need to find this distance, which is a distance of 4. So my radius is equal to 4, and my height is going to go the opposite direction from side to side, and it's just a distance of 1. So my volume for the cone, I'm going to say is 1/3 times pi times the radius squared, so 4 squared, and then times the height, which was 1. And I can take that and plug it into a calculator and get my volume. So 1/3 times by pi times by 4 squared and times by 1 ends up giving me 16.8 cubic units on the cone. And then I want to find the cylinder. And a cylinder's volume we can take by multiplying the area of the circle, which is the base, and multiplying it by the height. And the radius on this circle is still going to be 4, because it's that distance from the center to the outside. And then the height of the cylinder here is now going to go this direction, which looks like it's a distance of 3. So then my volume here for the cylinder is going to be pi times 4 squared multiplied by the height of 3. And if I multiply all those out, so pi times 4 squared times 3 ends up giving me either 48 pi or 150.8. So then if I want the total volume, all I need to do here is add those together. So total equals the combination of this and this. So if I add the 150.8 plus 16.8, I end up getting 167.6 cubic units. So units cubed, and that would be my total volume right there. So what we did here is we took our original shape, our trapezoid, revolved it around the x-axis, and created a three-dimensional solid. The left side of that, in the blue section, was a cone with a radius of 4 and a height of 1. And the right side, the green section, was a cylinder with a radius of 4 and a height of 3. We found those individual volumes, and then we combine those together to get the total volume of 167.6 cubic units.